So, hello everyone. Today we are going. This is the fine aggregate, and this is the coarse aggregate of 12 mm, and this is the coarse aggregate of 20 mm. So, as you are going to see here, for M30 mix design refers to a specific concrete mix design with characteristic compressive strength of M30 at 28 days of curing, and this is the pan mixer. It is used to mix the ingredients like coarse aggregate, fine aggregate, water and the cement. So this is the slump cone measurement of slump cone, and these are the cubes for measuring the compressive strength of 30 MPa. And this is the cement we have been used. And here all the ingredients like coarse aggregate, fine aggregate, and the cement have been mixed homogeneously. And the applications of this structural concrete and high-rise buildings, this design is suitable for structural applications such as columns, beams and slabs, and high-rise buildings like buildings, bridges and other infrastructure projects. So the considerations will be in terms of material selection, mix proportioning and quality control. The mix designs requires careful selection of materials including cement, aggregate and admixtures. And here the water is taken as 2.22 kg and cement as 4.93 kg, fine aggregate as 7.21 kg, coarse aggregate as 20 mm 10.52 kg, and fine coarse aggregate of 12 mm size 5.35 kg. Okay, so you can see here the cement is taken as 4.93 kg, and all the ingredients are mixed together in a pan mixer. So you can see here that is coarse aggregate, fine aggregate, water and the cement. And next here they are going to be mixed homogeneously. So the material selections and the mix proportion and quality control. The mix proportions need to be carefully designed. So you can see here the water is added about 2.22 kg. Slowly the water is added. The mix proportions need to be carefully designed to achieve the desired strength, workability and durability. The quality control, strict quality control measures are essential to ensure the mix design meets the required specifications. So this is how we are going to achieve the characteristic strength of this M30 grade concrete of 28 days. And now we are going to take out the ingredient mixture to measure the slump. So you can see here the slump has been going to be measured. That is slump cone test. The slump cone is measured for workability assessment to evaluate the consistency and durability of concrete, and also as quality control to ensure the concrete meets the required specifications. Prepare the slump cone, place the slump cone on a flat surface. After that, these ingredients are going to fill the cone with fresh concrete in 3 layers, dividing each layer 25 times. And next, we are going to measure the slump between the height of the cone and the highest point of the concrete. Now, for now, we are going to take out the ingredients, and we are going to pour the concrete, fresh concrete, into the slump cone which are kept in a flat surface. So now you can see the slump is going to be poured in a slump cone test to measure the slump. So here we are with the tamping 25 times. We are tamping the layer with rod with each layer 25 times. So carefully we should lift the cone vertically. So now you can see we are measuring the slump between the highest point of the cone and the highest point of the concrete. And after that we are going to interpret that slump value. The measured slump value indicates the workability of the concrete, as well as the consistency. The higher slump value indicates the more fluid consistency. So here we got the slump value as 110 mm. And after that we are going to cast the cubes to calculate the compressive strength, desired compressive strength at 28 days of curing. And here we are tamping each layer, 3 layers with the help of tamping rod. And here the applications of these slumps will be construction sites. The slump test is commonly used on construction sites to ensure the concrete meets the required workability and concrete production. The test helps concrete producers adjust their mix designs to achieve the desired workability. So this is how we are going to calculate the slump cone and the compressive strength of concrete mix design of M30 mix design with a characteristic compressive strength of M30 MPa megapascals at 28 days. And here the tubes have been kept on table vibrator. With the help of table vibrator, we are going to shake these for uniform settlement of the ingredients into the cubes. So now you can see here with the help of tamping rod, here 3 layers. With the help of tamping rod, layer has been applied, and after cast these cubes, we are going to calculate the 28 days characteristic strength. So now you can see we are going to do the characteristic flow table with table vibrator. The cubes have been kept on table vibrator for mixing of these ingredients. Okay, so this is the how we are going to calculate the M30 mix design. So we are okay. So next.